Hey everybody, this is Justin Romine with Goff Heating and Air Conditioning, and today's episode of Goff Tips, we're going to focus on the issue of indoor air quality. Indoor air quality has been an issue really for the last 3 years. We've had a lot of consumers asking us, being more concerned with the quality of the air in their homes. So we've wanted to really spend some time focusing on that. And we've been really excited to partner with Dynamic Indoor Air Quality Solutions and offer their product SolaceAir. It's been really, really great for us. And today we're going to learn more about that. We have the president, Steve Morris, from Dynamic. Really excited for you to be here. Thanks for being here.
Thanks for having me.
And we're just going to do a little interview and learn as much as we can. So appreciate you being with us, and let's get started. Steve, you mind telling us a little bit about yourself?
Well, I got into indoor air quality in 1990, kind of before it was cool to get into. As you know, being in the industry, there's a lot of people now kind of jumping on the bandwagon. Good competitors. We have a lot of good competition out there, but also a lot of smoke and mirrors out there today. And I know we'll talk a little bit about what you got to be careful with when you're buying indoor air quality or investing in that type of a product. But 1990, I had my own company. We were became the largest distributor of indoor air quality products in the Midwest.
Okay.
I merged that into another larger national company. And then about 15 years ago, I really got involved more in the manufacturing end of it. So I joined the manufacturer, Dynamic Air Quality Solutions, and we make the SolaceAir brand. We've been in business, Dynamic, since 1982. Not as old as you guys. I understand you're from the 30s, huh?
Yeah, Goff was started in 1937.
I had some bragging rights to 82, but it sounds like you guys got us beat there.
But I was personally born in 86, so yeah.
Okay, so we've been in business 4 years before you were born.
Yeah.
But we started off mostly commercial, and we still have a huge commercial division. So one of the things that we like to talk about on the residential end is what we can do commercially. We do hospitals, we do museums, we're in space centers. We're just doing a job at NASA now. So we've got a lot of credibility when it comes to the industry, because when you get into the commercial market, it's not like put it in and good luck. They do case studies before and after. So if a hospital is going to put our stuff in, they're not saying, oh, we believe these guys. You know, they actually do a before and an after test. So we've got hundreds of case studies. If you go online to dynamicaqs.com, you can read all of our commercial studies. So we take that commercial technology, and in about 1990-ish is when we started getting into the residential side. But first on the residential side, all we did was filtration, or we call it air cleaning. There's a difference between a filter and an air cleaner. Our cleaners, it's called a polarized media air cleaner. It's the Air Ranger we're going to talk about today. That was what we started with, but we found out that there's more than one phase of contamination. So we needed other products to supplement that. So fast forward to today, I'm president of the residential division. Once again, we have a commercial side, a fellow by the name of Mark Montesanto. He runs our commercial side. And they do all, like I said, the large hospitals and things of that nature. We're focused 90% in the residential, and then we do some light commercial work as well.
Yeah. Well, yeah, I know for us, those case studies were extremely instrumental in us choosing to go with SolaceAir and to use that product. Like you said, just knowing that some of the most important facilities in the world utilize this technology, it should be safe to say that we can use it ourselves and it will be taken care of. So,
Absolutely.
So yeah, again, appreciate you being here. Why don't you start by just explaining why is indoor air quality becoming such a big thing?
Well, it wasn't a big thing until about the 80s, and it really wasn't broadcasted like it is today. About 1973 is when we had our first oil embargo, and they started tightening up the homes.
Okay.
Prior to that, they most homes could breathe. You know, we weren't that concerned about energy usage. We didn't even insulate walls. Now we insulate. We use vapor barriers. Sometimes they foam insulate.
Right.
We have double, triple thermal pane windows.
Very tight.
Yeah. So we've tightened up the homes, and in the mid 80s is when most every home either being built or remodeled has been tightened up. So what that does is it locks in the heating and cooling, which is a good thing.
Yeah.
but it also locks in a lot of the pollution that we weren't even aware of. All the off-gassing from carpets, paints and stains, and cleaning chemicals. And then the bacteria and the viruses that can build up in our air handlers. That's one of the perfect breeding grounds for bacteria and mold and other mildew and stuff that gets into the air and causes that stale smell. But it also can it can affect our health. So the reason it's gotten more popular is mostly recently, obviously COVID helped, but even prior to COVID, in a sense, interesting, Justin, when COVID came out, our phones rang off the hook.
Right.
Can your UV light kill COVID? And I'm like, we've been talking about killing viruses since 1992.
Right.
God's been doing it since the sun was created.
Yep.
And then we've been using it in, or commercial applications since the 30s and 40s, and water treatment as well. So the technology is not new, but the application in residential is new because we really weren't aware of the challenges that we're having.
Yeah.
Now we got all these case studies. We got the EPA telling us we got indoor air problems, World Health Association. There's all these agencies now telling us that there's a challenge. So, and it's gotten, indoor air can be a lot worse than the outside air.
Yeah, and that's, COVID is exactly what I've always kind of pinpointed to, but once that happened, and then doing the research and realizing that, our indoor air, what I'm reading is that our indoor air is a lot worse than our outdoor air. So what are the challenges that presents, and how do we take care of that?
Well, what most people aren't aware of when you look at either outside air or indoor air is there's 3 phases of contamination. When people look at residentially, even commercially, the first thing you look at is the dust particles. You can see dust, you take that out of the air, but 98% of the particles we breathe every single day measure below 1 micron in size. So, and that's impossible to get out of the air with a filter, because with filters, we have to have the holes large enough to let the air go through. If we made the holes that small, 1 micron, if I took a human hair and I would have put it on the wall here and cut it in 150 pieces and put 149 of them here and take one that's left, that's a micron.
Yeah.
So, and this stuff is about a third smaller than that. So we're dealing with really submicronic, they call it, invisible particles.
Okay.
So the visual stuff is rather easy to get out of the air if it ever gets to the filter, but most of that's heavy.
Just stop it with the filter. Yep.
It's the small things that are in the air, the small submicron particles. And that's just the particle land. So it's difficult to get them out of the air, because if we kind of joke around, the best filter in the world is sold at Home Depot. It's called plywood. Take your filter out, put a piece of plywood in there. Now you're collecting all the particles, or you're stopping all the particles, but you get no airflow.
Yeah.
Our systems need to breathe. So in our industry, we look at 2 things. How can we get the small particles out of the air without preventing the airflow from getting through there?
Right. Yeah. We don't want to damage our furnace.
Right. So there's ways of doing that other than just to put a brick wall in there. So that's the first thing. Second thing is there's biologicals in the air, and we're very familiar with viruses now, but the viruses have been in the air forever. Cold virus, flu virus, we're still fighting that.
Yeah.
We're going to be fighting COVID for a long time, if not forever, but we've figured out ways to control it to help, when people do get sick.
Yeah.
Same thing with the flu and the cold. It used to kill people, and now we can know how to control it. And, there's other ailments there other than what can be caused by a virus. We got asthma, allergies. That's aggravated by dust. It can be aggravated by other things that are in the air. So on the biological end, basically germs, for a catch-all phrase, that would be your bacteria and your viruses. That filtration doesn't help that. So you need another technology for that. And then what most people aren't aware of, and we don't talk about a lot, and we should, the most dangerous thing in the air is the gas phase contamination. And that's the benzenes and the ethylenes and the formaldehydes that get in the air. And all of our furnishings and our carpeting and our paints and stains and cleaning chemicals, things that we use, and sometimes things that we're trying to clean the air with, we're spraying stuff in the air.
Yeah, the VOCs.
Yeah, read the label on what you're spraying in the air. Yeah, it might, if it's going to kill a germ, it might not be too good to put it in the air.
Sure.
So it's okay for surfaces, but to spray stuff in the air, now we got a challenge. So it all kind of adds up to this chemical soup we live and breathe in.
So that all makes sense. But you're from Chicago, right? And when I think of the outdoor air being cleaner than our indoor air, sometimes that's hard to fathom, especially in places like Chicago. So why is that? Why is the outdoor air cleaner than the indoor air in most of the studies that I've seen?
Well, you got to think of here again. Let's talk about the 3 phases of contamination. Outside, Mother Nature has a way to control them. Yeah, we pollute the air. You know, there's cars, there's factories and everything else, but you'll get a pollution alert day, and the next day it's okay. Well, what happened to it?
Yeah.
Well, Mother Nature has a way of taking care of it. And this is probably a subject for another podcast, but because we can get really deep into each one of them. But there's ionization, UVC energy, and UVV energy outside that cleans the air. Ionization takes care of the particles. UVC takes care of the biologicals, the germs. Okay. And then the UVV from the sunlight takes care of the gases. So Mother Nature has technology that's constantly controlling what's in the air. Now let's go indoors. We've tightened up the homes. We've got the same amount, starting off with the same amount. Then we're adding stuff in it. People are hacking, sneezing, coughing. We got off-gassing for carpets. We got, here again, paints and stains. There's stuff that's building up in there. We don't have ionization indoors.
Yep.
We don't have the UVC energy indoors. Even the UV that comes through your window, the window itself will block the UV rays.
Or if you're like my wife, you just block all the windows anyway. So
exactly.
No natural sunlight.
So the challenge is we got this buildup, we got these tight homes, and the outside air technology is not indoors. It's not naturally present indoors, so that's why we have a problem.
That makes sense. Yeah, like I said, we've been using SolaceAir now for about 6 months. Been really impressed with it. We've gotten really good reviews. I use it in my house. Noticeable difference. But yeah, can you explain to us a little bit how your particular product solves these issues within the indoor air quality?
Well, it's interesting that basically what we're doing is taking the technology that Mother Nature uses outside and put it inside your air handler. So we already mentioned there's 3 phases of contamination. We'll probably say this 20 times during the interview here.
Right, but yeah, let's do it.
There's particles, germs, and gases. Okay, you need to address all 3. And there's a lot of products out there that they'll claim they do all 3, but Mother Nature outside has to have 3 technologies to do it. So there's not one technology that can do all 3.
Okay.
So you have to have something that's going to address all 3 phases of contamination. First thing is filtration. You can put all kinds of filters in there. You can go to the hardware store and there's a billion kinds of filters. There's filter aisles, Right. Well, what you have to understand about filtration is the higher you get in a filter grade, then the higher the pressure drop or the resistance to the air goes. And you guys run into that all the time.
It's very important. That is probably the number one call we get is the lack of airflow. Even it's somebody, I just put a brand new filter in and they just got it from the store and it's a really high MERV, but it's not allowing the airflow for that furnace or the air conditioner to function properly, and it's causing problems.
Yeah, even if, sometimes they'll put it in and they'll say, well, the fan's still on, still working.
Right.
But they don't realize that it's making that system work so hard. Their energy costs are going to go up. The system's going to work harder, so it's going to break down quicker. So all those things we take into consideration. We want good airflow, but then how are we going to collect the little guys? Not the 90 or the 2% that you can see. It's the 98% that's invisible. How are you going to get that out of the air? You can't do it with a filter. We already explained that if you make the holes that small, now you're going to block the airflow.
Right.
So we use a product. It's called, we designed it in 1982. It's been refined since then. That was the iPhone 2. And now we're at the iPhone 15 now with our product. Technology is the same. We've improved it. We've made a lot of changes, even in the last few years.
Okay.
Most of that's been cosmetic and structure changes to it, but the performance is the same. So the particles in the air are charged. They're either positive or negative. And that Mother Nature does that. It's already happening.
It's a science lesson.
Yeah, this is a science lesson.
Okay, good.
So if we know that, then we'll know the opposite charge should be able to hold it, collect it. So like a magnet grabbing paper clips.
Right.
So with a polarized media air cleaner, it's called, the name of ours is an Air Ranger. What that does is it creates a charge, and it's you guys wired into a transformer. Now we got 7,000 volts of energy into a media pad, but we let the air go through. If you hold it up to light, you could see right through it, and almost like a fiberglass filter. So, well, how is it collecting anything if I can see light coming through it? You take a MERV 12, some heavy duty one at the hardware store, you can't see anything. You can't
Right.
see light coming through.
Right.
it.
It's got layers and layers and layers.
Right.
Yeah.
So we want to be able to collect that, but allow for airflow. So we rely on some science. The opposite charge. So we have these fibers in there that take a charge off this little power head. So every fiber has a positive side and a negative side. So picture a magnet inside there. And there's millions of fibers in there. So as the particles coming through, the positive particles get attracted to the negative side and negatives get attracted to the positive side.
Okay.
That's the first part. Now you got to have a high enough voltage to hang on to it.
Yeah.
There are products out there, electrostatic filters, that'll do kind of the same thing with a static charge, but they don't hang on to it. The fan goes off, it drops down, or it loads up and it can only hold so much and lets the other stuff go. With a polarized media air cleaner, you're basically magnetically holding it, and then you're burning it out. It's called electroplating. You burn it onto the media itself.
Yeah.
So even if it goes off, you shake it, it can't come off. It's physically becomes bonded to the fibers.
Yeah.
So we're allowing for good airflow, but now we figured out a way many, many years ago of how to kind of act like Mother Nature does outside. How are we going to remove the particles, not just kind of place them somewhere else? If it's going to come through the air handler, we're going to physically plate it onto that media, and then that media is changed about 3 or 4 times a year.
Okay.
And we get a new air cleaner basically every 3 or 4 times a year.
So that takes care of the particles, right? So what micron level? Because we were talking about microns earlier. What micron level does that take care of the particles?
That's a great question, and it's a long answer, but the short answer is if you look at particle sizes, most of them are about 0.3 microns in size.
Okay.
You get larger, like 20, 30 microns. That stuff exists, but it falls out of the air. I'm talking about stuff that's permanently suspended in the air.
Okay.
You get below 0.3 microns, now they become gases. So it's that 0.3 microns. We're at 97% at 0.3 microns.
Yep.
We'll collect smaller than that too, but now we're going to get to a point where it's not even a particle anymore. It's a gas. We'll talk about that in a bit.
Yeah.
So, but that's the particle size that we're tracking, 97%. A HEPA filter is 99.97 at 0.3 microns. We're at 97.
Okay.
So we're almost at HEPA filter quality.
Yeah, it's very close.
And then the next phase of contamination, which filtration and air cleaning doesn't address, are the germs.
Yep.
So the viruses,
Which is with COVID. That's again, we've seen that a lot of people are really concerned about.
It's always been there. It's just the awareness level skyrocketed.
Yep.
You know, I don't think there's anybody in the United States or around the world now that doesn't know something about a virus today.
Yeah.
You know, one of the things they may not know is that this, like when we got the calls when it first started happening, is like, can you do it? And I roll my eyes and like, geez, we've been talking about killing a virus since 1992, and prior to that with commercial, and prior to that with the sunlight. Yes, it'll do it. So I'm going to simplify this, but viruses are a protein shell with like some liquid in there, and then it's either RNA or DNA inside there. That's it.
Okay.
It doesn't have wings or legs or hearts or lungs. You know, it's pretty simple microorganism.
Yeah.
So if you could break into that protein shell, which you can do with UV light, you're going to expose the inners of that, and now it'll disrupt the RNA or DNA and stop it from multiplying. So, you know, when people say, can you kill the virus? The answer is no, because it's not alive. We can inactivate it. We can stop it from multiplying. And that's what we want to do. We want to get viruses that are coming through the air handler, and we're taking 3, 4, 5 air changes an hour. All the air in your house is going through your furnace. And so we got many opportunities to do this. So even if someone sneezes and it gets in the air, it's going to come around.
Sure.
You know, and we're not going to, I mean, if I sneeze in your face, the UV light's not going to take care of it. But for the most part, if you're, you know, covering your mouth while you're sneezing and you're, you know, kind of quarantining yourself and that, then we're going to take care of the stuff that's in the air. We do that with ultraviolet energy, same energy that the sun creates. Sun creates all kinds of different energy, gamma rays, X-rays, and all kinds of cool stuff. There's a section called ultraviolet energy. It's UVA, B, C, and UVV.
Okay.
A and B penetrates the ozone layer, and that's what comes down here, helps plants grow, can give you a skin tan, helps your body create vitamin D. That's good stuff.
Yeah.
UVC is a very dangerous wavelength of light, and the ozone layer or the stratosphere protects us from that. So not much of that gets down here.
Just enough.
Just enough.
Yeah.
And Don't ask me how. Mother Nature knows how to control it.
Yeah.
Just enough to inactivate the most microorganisms.
Yeah.
It's kind of like if you look at a tree, the moss grows on the side of the tree that the sun doesn't shine on.
Yeah.
Because the sun's shining on it. It has to see it. So when we're using UVC inside, and that's the wavelength it kills, when we put it inside your furnace, and we have one right here mounted to a return drop. So as the air is coming down the return drop there, the UVC has if you have enough energy, there's a lot of UVC lights out there. You need two things to kill it or to inactivate it. It needs to have the right wavelength, UVC. UVA and B lamps, that's what they use in tanning salons. If I use the UVA or B lamp and put it inside air handler, it's not going to do anything.
Right.
Unless you lay inside there and you want to get a skin tan.
Yeah.
UVC lights, if you put that in a tanning salon, your skin would be bubbling in about 5 minutes, So it's a dangerous wavelength. It'll burn the skin, burn your eyes. And we even tell technicians when they're installing it, be careful. But it's not going to hurt a homeowner because it's inside the air handler.
It's contained.
The duct. It's contained. But we need that energy, the right UVC energy, but then we need enough power. So there's UVC energy lights, and the power of UVC is measured in microwatts. If you want a higher light bulb brightness, you get a higher wattage. If you want more power in UV, you get higher microwattage. So, and there's a mathematical formula we work with trial and error and studies. We know that it takes at least 110 microwatts at 1 meter away to inactivate a microorganism. Actually, 1,500 microwatts within a foot of the lamp. And that's how we work our systems is we know that we have to have enough power in that lamp within a foot of it to be at 1,500 microwatts. And we do that with the SolaceAir active Bioforce.
Yeah.
So that's the next thing that we need to take care of. UVC, but then have enough power. Like the analogy we use with technicians when we're training is if I lit a match, would it be hot? And they all say, well, yeah, you can burn your hand on it. Well, can I heat a house with it? And they say, well, no, that's stupid. I said, why not? It's heat.
Right.
It's not enough heat. It's 1 BTU. How many BTUs does it take in a furnace? It's tens of thousands, right?
Yeah.
So same thing with UV. It's the right match. It's the right wavelength, but it needs enough of those matches. So that's where we get the microwatt output. And then the last thing is the gas phase contamination in the air. We absorb some of that into the filter, but not a lot, into the air cleaner. So we need a third technology, and it's UVV energy. It's another wavelength of light that has a reaction with the gas phases that come through there, and it makes them safe. So you can take formaldehyde and break it down. Yeah. But it doesn't in ductwork. It doesn't add anything into the air. Yeah. So those are the three things that we put together to take care of all three phases of contamination.
Yeah, that's really good. So we're attacking it basically holistically, right? When you have the Air Ranger, right, and the active Bioforce, which has the UV lights, and I will say that the UV lights in comparison to anything else that we've seen are significantly longer, bulkier. You can tell that you're getting more out of that, right? And then you have the ozone. Can you explain a little bit, because I have had some customers a little bit worried about ozone, right? It's dangerous.
I would be worried as well.
Okay, so how do we navigate that?
Well, we call it UVV so people don't get freaked out. And really, we'll have our competitors say that our light doesn't create any ozone. And technically speaking, the light itself does not create ozone. Okay. It creates an energy. It creates a UVV energy, a different wavelength of light.
So just a way to get around that.
Right? Yeah, so we could say the same thing. But, what happens is the reaction, you got oxygen coming through there. The UVV light shines on the oxygen, and oxygen's O2. Yeah. It breaks it up. Now you got two O1s. Those O1s hate to be O1s, so they're going to join something. Yeah. Usually with the first thing they do, they can join another O2, down to O3, that's ozone. But it's very unstable. So that third atom that's on there, you got O2 plus the O1, its job is to go floating around the air looking for a gas molecule. We've got tons of gases in the air. Okay. So once it sees the gas molecule, it releases it, converts back to oxygen. So what we're doing is the air has 21% oxygen in it. So we know that we're going to have oxygen coming through that air handler. So if we have a small, tiny UVV light that does not create ozone, it creates UVC energy. But when the oxygen comes by it, it'll create this ozone, but it's inside and encapsulated in the unit. Where ozone's bad is there's units that create ozone in the breathing space. That you can buy boxes, ozone generators.
Yeah.
And I see, we go in people's homes and like about knocks you over. Oh, it's supposed to purify the air. Well, it'll get rid of all the gases, but then it'll overproduce ozone.
Right.
Now, you go outside today, you're going to breathe about 50 parts per million of ozone every single day of your life.
Yeah.
You can take an ozone meter and read it. Mother Nature creates it to oxidize gases, but it's not an overabundance of it.
Right. Just enough.
Just enough. So when you measure it coming out of our supply vents, it's not even measurable. If I put it right inside the air handler, I can see it, measure it. But it gets used up doing its job very quickly. Within about 10 feet of the unit, it's gone.
Yeah.
So the concept is, let's get the UVV inside the air handler where we know we're taking 3, 4, 5 times an hour. All the gases, all the particles, all the germs are coming through that air handler. Now we're going to attack it with it inside the air handler. Mm-hmm. Sometimes when we're doing training and we tell a technician, it takes 50 parts per million outside, and we say we don't have any inside the house. They're like, well, then how the heck are you doing it?
Right.
Well, we're not doing it here.
Right.
We're doing it there.
Right.
So because of that, we're not adding any bad stuff to the air because we're taking care of it inside the air handler. But we need it to take care of the gases.
Right.
But we don't want it in the breathing space.
Yeah, I think in a lot of ways, anything, if you have too much of anything, it can, even a good thing, it can be harmful, right?
Well, that's the analogies we give all the time. I said, if you have a headache, do you take 2 aspirins or the whole bottle?
Right.
2 aspirins get rid of the headache. You take the whole bottle, you wake up dead in the morning.
Right.
You don't want to wake up dead, right?
Yeah.
A glass of wine a day is good. A gallon of wine a day is bad. You can go on and on and on.
Even water, like, drink a lot of water. There is a point where you can even drink too much water and it can be harmful to you, right?
The only caveat to that's good, coffee, you can drink as much as you want.
That's true. I agree with you. I agree with you on that. Yeah, and in the active Bioforce, for the ozone particular, there's a mechanism in there, that shroud, that allows for you to make sure that you're not putting too much, but you're just getting enough, right?
Yeah, well, and then the question comes, well, how much, where do I set it at?
Sure.
Well, if you set it at high on anybody's house, it's going to be used up before it gets there. Here's the only reason we have that little adjustment there. Some people are hypersensitive to smell. And even though we're at less than 1 part per million, 50 times less than outside, some people can smell it. It depends on the size of the house. So instead of saying, I'd say 85% of the people say, wow, I don't know what you did. My house smells great. They're smelling the lack of smell.
Yep.
It got rid of the cat odor smell.
Yep.
It got rid of the litter box. It got rid of the cooking smell. That's what it does. All this organic stuff that's in the air. So it's a freshness. Occasionally someone says, that's kind of like a weird smell. I really don't like it. Well, then that's why we had the adjustment. But if you adjust it too far down, it's got to do its job.
Yep.
So we tell technicians, go ahead and leave it on, and unless someone says I don't like it, then we just usually turn it about halfway. That's why we had the adjustment.
Yeah.
That way we can have one unit fits all.
Yeah.
It probably won't work as fast because you just cut half of it off. But for those people that are hypersensitive to a smell that might not like it, then there's an adjustment there.
Yeah, I know for me personally, we live in an old home and have that musty smell, and it definitely got rid of that. So yeah, and I used to work in the hotel industry. So taking care of, like, if somebody smoked in a room, you would put an ozone machine, but the protocol was you couldn't
get the heck out of there.
You got to get out because it would put so much in, and you could absolutely smell that ozone smell, but you couldn't smell the smoke. So the whole goal of this is to get rid of the formaldehyde, the things that, the chemicals that are not good for us, right? The volatile organic chemicals that are in the paint and carpet that, again, aren't good for us. And yeah, the musty smells and the cat odors and stuff like that.
Well, let me address what you just said about hotels. Sometimes we go to a lot of hotels, and not every cart that the girls have or guys that are cleaning a room has this, but you'll see a little box there with a plug on. That's what that is. It's an ozone generator. You're not supposed to smoke in a room. That doesn't mean people don't do it. And smoking other things as well. But these days especially. So, and I smell it sometimes walking up and down the hallway. So even though there's like a $250 fine if they go in and they have to clean that up.
But you can't enforce that.
So the point is that there's an odor in there that they need to take care of. Sometimes there's other odors in there, they still do it, but they turn it on, it's got a timer on it.
Yep.
They tell the maid to get the heck out of there, put a little sign there saying we're fumigating this room. Now you are filling that room with ozone, which is not a good thing if people are in there. It's a good thing to get rid of that. So, and it takes about 16 minutes for it to deplete itself. So once it turns off, they'll have a timer on for like an hour and then it'll go off.
That's exactly. So we would set it, we had to put the time that it was set, and 2 hours later we could go back into the room.
Okay, good. So then you had a protocol there. The other application for that is if you had someone had a flood in the house or they had a fire.
Yeah.
My neighbor's house had a big fire and it took them over a year to remodel it. I remember I was traveling and my wife called me up, hey, they're wheeling in 2 big machines. They're bringing in 2 ozone machines. Mm-hmm. But they lived in a hotel room, for a week. They blasted that place with ozone. That's an application for that type of ozone in the breathing space. Mm-hmm. What we're doing is maintenance. It's that we're bringing the gases to the ozone generator, not the ozone to the gases.
Yeah.
Because we know that the gases are going to come through this air handler. And we're not handling it all at once.
Yeah.
We're not taking like 20,000 cubic feet of air and trying to do it all at once like they are with those machines. We're doing like 1 cubic air at a time. So we don't need a lot to do it. And that's why it's used up in doing its process.
Yeah. Well, yeah, let's get a little bit into, so obviously this takes care of the overall health in the indoor air quality, making sure it's not poor and, we're not spreading the viruses and the bacterias and the chemicals we're not breathing in. But one of the things I love as a technician and as a company is how it protects and is healthy for the equipment itself, mm-hmm. and enables a greater longevity. That's been our job for as long as we've been in business, to keep your equipment running, efficiently and safely. How does this product particularly aid in that?
It's really helped recently in the last 10, 15 years when we got higher efficiency equipment. In the old days, you had a burner and a pilot light, and now we got secondary heat exchangers. Yep. We got coils that are more dense. That it was always important to keep things clean, but now it's more important than ever now. Mm-hmm. Because the stuff that's in there, there's been a lot of studies done on coils. A lot of people that might be listening to this, when we ask the typical homeowner about heating and cooling, they think the outside unit cools and the inside unit heats. Yeah. And the outside unit sending something to the inside unit to make it cool. Yeah. So really the air conditioner is the whole air handler. We just happen to have that unit outside to make it happen.
Yeah, you're indoors. Actually removing the heat from the house.
Yeah. So we got a big steel coil in there. If that gets dirty, there's many studies done. EPA's done studies. There's Prism Engineering, and a lot of engineering firms, the airflow guys have done studies. Mm-hmm. And what they've shown is 1/20th of an inch buildup on the coil, which is about the thickness of a business card. Mm-hmm. If you ask any technician, have you ever seen that much dirt on a coil? Yeah, every day. Sometimes it looks like a dead animal pelt you got to peel off, Yeah. So it can get really bad, but it doesn't take, it's just a dusting, reduces the output of that coil by about 21%. Right. So think of that. Take your energy costs and increase it by 20%, or decrease it if you kept it clean. Yeah. One of our technicians explains it great to a homeowner. He says, you know what a koozie is, right? Yeah. You got a cold can of beer or pop beer, you put it in a koozie. Why do you put it in a koozie?
Keeps it cool. You want to keep your hand warm.
Yeah, right. You want to keep the cool or the heat inside there, right? Right. So it says putting a little layer of dust on the coil is like putting a koozie around it. It'll still create the coolness or transfer the heat, but not as well if you put something around it. Yeah. So we don't want a koozie around the coil. We want to keep it clean. We want to keep it off so it can get its job done. So that little dusting is, almost everybody has that. But if you don't have good filtration, now it's going to build up on there. It's also going to build up on the blower wheel. Yeah. There's a fan in there, a squirrel cage fan, that's spinning around. It's got these little curves in there to scoop in the air. As it's scooping the air, it's creating enough CFM to put the heating and cooling inside the home. If you fill that scoop up with dirt, it doesn't take a lot. It's like 1/8 of an inch, according to Texas A&M has done studies and other airflow people. If you fill it up, it can't scoop air anymore. Now it's like paddling the air. So it's going to take more revolutions for it to get the heating and cooling inside the house Now your system's going to run longer. It's not going to run as efficient. And the thing is, the dirt and dust is not prejudiced. If the coil's dirty, the blower is going to be dirty.
Yeah.
So now we're creating, people are buying these 18, 20 SEER systems with 95.5% efficient.
You're losing all that, yeah.
Well, I'll ask a technician. So if it gets getting dirty, is it 18 SEER 6 months from now?
No,
well,
absolutely not.
That's what they say. But truly it is. Look at the label. It still says 18 SEER.
Sure.
It's not going to act like an 18 SEER. And if you're going to pay big money for this higher end equipment to save energy, and you're going to get it dirty and it's going to decrease, you might as well buy a cheap 80% to begin with if you sell those anymore.
Yeah, or the minimum SEER, 13 SEER, 14 SEER now, yeah.
So there's 3 things we look at with the equipment. We want to run at peak efficiency. We want it to last as long as possible. At least the homeowner does, at most homeowners we talk to, and they don't want any breakdowns.
Yeah.
But if the system's going to run harder, run longer, just like a car, if you're not getting good gas mileage and if you're running on a highway, it's getting better gas mileage. You're running stop and go in a city, it's going to work harder.
Yeah.
If we get the system to work, if it's starting to work harder, it's going to stress the capacitors and the contactors and the stuff that's in there. If that stuff starts to work harder, it's going to not last as long.
Right.
And we want to protect that from happening.
Yeah. Yeah, it'll restrict the airflow to the places that it actually needs to get to. And I read a study that, the old copper A coils, they were notorious for leaking. And the study that I read, that it was actually the VOCs in the house, right? So now we have a chemical that's helping to break down the equipment. And the coil naturally is going to sweat, produce moisture. And that moisture in the VOCs and the copper, when a corrosion starts to happen,
Absolutely.
And then it develops that pinhole leak. Now, newer equipment, you're going to have the aluminum coil to resist that. But in the older coils, having a system like this to even mitigate that, the VOCs is going to help from having to change a coil out.
Well, let's go back to health again. If the VOCs can break down copper in a unit, just think what it can do with your lungs.
Yeah.
So
Well,
I'm
that's a
not
good
trying to
point.
scare people, but it's in the air. I mean, just go Google it,
Yeah.
And if it's on the internet, it's got to be true, right? So, I mean, you got to kind of sift through the stuff in there. But there's tons of information out to tell you about the VOC control, why you need to control in bacteria and particles as well.
Yeah. Yeah, so you've talked all about the UVC, the UCC.
UVV.
Or UVV, and the UVC. So particularly that's in this unit here, it's called the active Bioforce, in conjunction with the Air Ranger, which is the filter. How effective are those in eliminating germs and the infectious agents?
Like we talked about before, is there's the 3 phases of contamination once again, and the second phase are the germs and particles, and we like to call them bioaerosols. It's living stuff that's in the air. The filtration, the way a virus, when you sneeze, the way it doesn't have wings, it doesn't have feet, it can't run, it can't fly.
Yeah.
The way it gets from here to here is either hitching a ride on water vapor, which is humidity, or it can hitch a ride with a dust particle. So if we can get dust out of the air, control humidity, we want to eliminate, we're going to reduce the amount of bacteria or viruses that are going to get from here to here. So filtration, here again, it's filtration or air cleaning is not going to kill it or inactivate it, but because we're taking its transportation stuff out of the air, we can help it from going from one place to another. But to inactivate it, then you need UVC energy. So that enough power, enough matches. Remember we talked about that. As long as you have enough power, and you mentioned that ours it's just not a stick unit. When you look at our unit, it's actually a 32-inch lamp. It's just bent like this.
Yeah.
So we can get enough of the microwatt output. The way you get more output is to have a longer lamp. We can't put a 32-inch lamp and it would stick out the other side of the plenum.
Yeah.
So what we've done to is we bend them. So you just get the arc that's traveling 32 inches. That's how we get enough microwatts out.
Okay.
So, and it has to be there according to ASHRAE. ASHRAE is our governmental agency that just for the audience, that's who regulates SEER ratings and how efficiency equipment is. They finally come out with some studies and some standards that says it takes 1,500 microwatts to inactivate most, if not all, microorganisms. And you have to do that within a certain amount of time. You only have about 0.7 seconds to happen because it's going that fast through the ductwork.
Wow.
So you get about 2 feet span, and it's saying 1,500 feet within 1,500 microwatts within 2 foot span. Our unit has 1,500 microwatts on one side and 1,500 on the other side because it's a lamp.
Yeah.
So we have enough in that zone.
Yeah.
We call it 180 microwatts, but that's measured at 1 meter away. The closer you get to it, the higher the intensity is.
Yeah.
Right. So 1 foot on either side, we're above that 1,500 microwatts. So we got that zone in there where we can inactivate those microorganisms as it's coming through. We're not going to do it in the air, but the air handlers are designed to take all the air out of the house and put it through the air handler so we can heat and cool it. And that's an exact spot that's perfect area to inactivate microorganisms as well.
Okay. Yeah. So by circulating that airflow, we're the way that those germs, I mean, that's what we call them, right?
Yeah.
Is
it's
the
the easiest
germs.
phrase to use.
Yeah. They're traveling now in through the furnace system, the blower system, and being filtered out through that UVC and UVV. Mm-hmm. So another question we get a lot is, you run into the consumer that had just purchased an air purifier that they can stick in a one room, a bedroom, or a living room that they got off Amazon and or Home Depot or wherever. What's the difference between this product, right, that in my mind has been sized properly, has been it's going to be installed properly, the research and development has been there. But from your perspective, what's the difference between those two products?
I'll answer that two ways. The first thing is most of them they're called room air cleaners because they're designed to clean one room.
Right.
So the fan in there is only strong enough to take enough air out of there and put it in this box to clean. A lot of them are HEPA units, and that's excellent. If you have somebody with severe asthma and allergies, even if you have our stuff in there, which is going to really clean the air well, sometimes you want to supplement that. It's okay to put a HEPA filter in there.
Right.
The challenge with a room air cleaner, though, is now if you were in that room, you sealed the room, and it can handle so many square foot. It's usually about the size of a big bedroom. Okay. If you open the door to that bedroom, it's going to try to clean the air throughout the whole house, and it's not strong enough to do that.
Up.
So even though it's the right technology, it's a good HEPA filter. The only way it's going to work is if it's in that room with the door closed. Okay. And if you want to do the whole house, you're going to need one in every bedroom, 2 in the living room, 1 in the kitchen. Now you're in there about $250 a piece. You start adding it up, you're in the $3,000, $4,000, $5,000 just to do the whole house. And now you got a lot of energy you're using, a lot of fans that are on. Mm-hmm. We're relying on we already have something moving air, and it's taking all the air in the house. Why do we need all these boxes putting around? So that's that end of it. The other end of it is they try to put all this technology that we have in that same box. Now, remember, you were talking about it's got to be sized correctly in there.
Right.
They can't put a 32-inch lamp inside that little box. So they'll put these little 5-6-inch lamps in there. And some of them, this one drives me crazy. There's a vacuum cleaner company that has a UV lamp inside the vacuum, and it says it's going to kill the germs in the carpets. There's a couple. First of all, if it was a real UVC light, and your dog or a little baby was crawling and looked at that light, it would burn their eyes. Yeah. So it's not it's a UVA light, or maybe it's just a black light. I don't know. But let's say it was UV, the regular UV light and the right power and stuff, and you're vacuuming like this. It's not in contact long enough. Yeah. So if you want to do the whole carpet and kill everything, you'd have to walk an inch every couple seconds. It would take you a week to do your carpet, then you have to do it again. Yeah. And it would fade the carpet. UV is gonna break down the fibers in there. So, and I'm kind of going off on a tangent with vacuum cleaners, but I mention that because it does drive me crazy. Yeah. But these other boxes, they'll put a little UV light in there, not enough power, not enough contact time, even though it has UV. I see this, my dentist office has them in every room. During COVID, they said that I don't know if they read it in a dentist magazine or whatever. Yeah. They got these little things, and I can tell it's got UV or a blue light in it. Right. But it's not going to take enough of it out of the air to get in that little box to get the job done. Right. So they're not powered correctly. They're not sized correctly. If they are sized correctly, they're sized for one room. Ours is sized to handle all the air coming through the air handler.
Right.
So we're whole house air cleaning as opposed to room air cleaning.
Yes.
We're using the right technology. It's sized correctly. It's installed correctly. It's going to have enough power to get the job done.
Yeah.
So what you're dealing with, and if you buy something, there's stuff you can buy on Amazon. You can install yourself in an air cleaner. into a furnace.
Yeah.
It's not going to have enough power. It's not going to. Are you wiring it right? What's the warranty on it? What if you put it in and you burned your eyeballs?
Yeah.
There's certain things that we train on, and that's why we go through,
The
legitimate
rigorous
contractors
training.
like yourselves.
Yeah.
So there's a lot of problems with the unit itself and what it can handle. The ones that can handle it only can handle one room. You got to make sure it's a tight room. But I'm not against using a HEPA filter inside a room. But if you're combining other technology in there, it's just not going to work. You just don't have enough inside the box to get the job done.
Yeah. Yeah, so we've addressed the infectious agents, right? The particulates, the gases, and how this kind of all-encompassing takes care of all those things, and the fact that it is whole house. So if you have, obviously you have to have somewhat of a proper duct design where you have return and supply, so it's pulling that air, it's cleaning it, right? It's not killing it like you said, but it's neutralizing, so to speak, and then dumping it back out. But you're doing it with the whole house. One of the things that I will say some people have expressed concern is the sustainability of it, right? Like how much is it going to cost? Not just the upfront cost to properly install it, but what is it going to cost to, the way it's described, it seems like this really high-powered light that just takes care of all this, bad things in my air. Can you talk a little bit about the sustainability of it?
Yeah, that's a great question because most people look at the initial cost. It's really an investment, because first of all, we talked about how it could save money on the energy itself.
Sure.
The unit's going to run more efficiently, your furnace and air conditioning system. It's going to last longer.
Yeah.
So there's actually a return on investment for having, let's forget about health for a reason, for a minute.
Yeah.
The unit itself, just on the protecting the equipment alone, there's a return on the investment there.
Yeah.
The system's going to last longer. You're not going to have as many breakdowns, and so they're not going to, unfortunately, they're not going to be calling you out that often.
Yeah, that's.
But it's still, the system still needs to be maintained.
Right.
A couple times a year, you should be checking out, make sure everything's okay. But since it's going to run at peak efficiency, not run as hard, those parts and pieces in there are going to last longer.
Yeah.
So if you do a cost of ownership, the units pay for themselves in 2-3 years.
Yeah.
Whatever it costs to put that in, if you look at what you're saving on energy, what you're saving on downtime from service calls and the cost of that. And let's get into health for a minute. Asthma and allergies. Well, we have documented cases of people saying, my kid's off an inhaler now.
Mm-hmm.
The interesting thing is we do not cure asthma and allergies. We get rid of the source that aggravates it. You're going to still have asthma and allergies. I'll love to tell a story. I had a lady about 10 years ago called me up and she said, hey, this contractor put this in. Excuse me. He said, this is going to cure my asthma, my allergies. She has some allergies. And she goes, I feel worse. And I said, how's that possible? They had a bypass HEPA and a polarized media air cleaner and UV light and UVV. I go, man, you got the best system that we know of.
Yeah.
And I said, well, let me send the contractor back out and make sure that everything's wired correctly and everything. I was kind of buying some time, but I couldn't understand it. So I call the contractor back and he says, I was out there. Everything's perfect. It's running great. So I called her back and I said, have you been tested for your allergies? And she said, well, no, I can tell I got a problem. I said, well, why don't you get tested? And maybe let's figure out what it is and we'll address that source. She called me back in 2 weeks and she goes, Steve, I'm glad you had me get tested. I found out I'm lactose intolerant. So, all the air cleaners in the world are not going to stop her from eating cheese and milk.
Yeah.
So there's our asthma and allergies, or allergies, I should say, stuff that we can't take care of. But the stuff if it's airborne, we're absolutely going to take care of it. And we're going to lower medical costs. People are going to feel better. They're going to not be going to, getting oxygenation or whatever they do. They go a couple times a year to, because they have breathing problems.
Yeah.
Here again, we're not going to eliminate it. We're not going to, I'm not going to say that it's a cure, but if we get rid of the source that's causing the problem, then you're not going to have the problem.
Yeah.
Or it's not going to be as severe.
Yeah. That's good. So you're taking care of not only the longevity of your equipment, but now your quality of life, right? And that is important. It's something that really matters. So you mentioned the HEPA filter. We haven't talked about that. You wanna say anything about the HEPA? I know normally when I go into a household and we're looking at how can we solve your indoor quality issues, that's the premium expense. I normally tell people this is if you want your home to be hospital grade, we can add this HEPA filter as well. But yeah, go ahead and share a little bit about.
Yeah, that's interesting. We never had a HEPA filter 15 years ago. I was actually sitting at a lunch meeting with one of our engineers, and we were talking about, he goes, well, why don't we just use HEPA inside an air handler? I says, if I put a HEPA in that side air handler, I'm going to block the air.
Yeah.
I mean, they're very dense.
Yeah.
And he goes, well, what if we bypassed it like we do humidification?
Yeah, absolutely.
And I'm like, how's that going to work? How much air are we going to do every time? So we designed a system, tested it, not in a little tiny lab, actually in a home, in 3 different homes. And we took a laser particle counter without a filter in, just a HEPA that's mounted to the side of an air handler. And so as the air is coming through here, we're taking about 30-40% of the air out, running it through a HEPA with its own fans, so we're forcing it through.
Okay.
And putting it back into the return. So there's no resistance to airflow because it's not in line with the air handler. But now there's 2 reasons we came out with it. Number one, there are some people that say, is your polarized media air cleaner HEPA? Because my doctor says I have to have HEPA.
Gotcha.
The answer is no. It doesn't. It can qualify as a HEPA because it does the same thing, but a HEPA by design has to be a certain thing.
Yeah. And
it's not that certain thing. It's polarized media air cleaner, even though we're collecting 97%. But then we can't use HEPA in line, otherwise we would.
Yeah.
So that for people that say I have to have HEPA, I say, well, we need the polarized media air cleaner because 60% of the air is going to go through here. We'll add the HEPA so you can tell your doctor you have HEPA. Now, that's a good thing. But the other thing is, if you want a double whammy, really, if you have really severe asthma and allergies and you want to get it out faster, you might as well do it with a polarized media and a HEPA. So when we put our packages together, the IAQ 4000 has everything.
Right.
So, but it is a bypass. It's not going to take all the air at once, but it's going to take a lot of the air and get it 99.97% clean.
Yeah.
So you do that combination with the UV and the UVC and UVV. Now you get the best of all worlds.
Yeah.
The typical homeowner doesn't need to have a supplement of a HEPA.
Yeah. I would
unless
say
it's
the
really
IAQ
severe.
3000, which has
It's the most popular.
Yeah, we've seen a lot of people have interest in that. Well, great. I appreciate this conversation. I'm a little bit curious about the future of IAQ. I know it's become kind of a hot topic. Indoor quality is a buzzword. You get on the internet and it's there's all these forums and all this stuff on it. Anything you can tell us about the future of indoor air quality?
I think technology-wise, I don't think I don't know how much more we can improve a UVC light to do what it does. I think what's going to happen in the industry is a lot of this smoke and mirrors out there is going to be found out that it doesn't really work. So a lot of that's going to go to the wayside. People are becoming much more aware. They're doing much more studying. Contractors like yourselves are taking the time to educate themselves so that your technicians, your salespeople, your comfort advisors all know that this is what we're doing, this is how we're doing, this is how it works. This is really real stuff.
Right.
So I think the awareness level is skyrocketed, especially since COVID. So technology-wise, I really don't see much changes except for the room air cleaners with people starting to put a bunch of stuff in there. There's some out there that have photocatalytic oxidation, UVC, UVV, but the ozone's got everything you can think of. But here again, it's in a box that it can't take enough of the air and it's going by too fast for it to do anything.
Sure.
So I don't see technology changing a whole lot. I do see commercially people getting more and more involved with it. Always the hospitals are, nursing homes, but now school districts are getting into it.
Yep.
And but the challenge that they're having is it's run by a school board. It's mom and pop that doesn't know anything about the technology. So that's where a lot of these guys with science technology that's not logic has been put into these lot of schools. And there's class action lawsuits now because the stuff they put in didn't work. Actually, it made things worse.
Yeah.
So contractors are going to get more educated on what's good, what's not good. Man, and I'd love to sit here and tell you that SolaceAir is the only product that works. We got some great competitors.
Sure.
But at the end of the day, there's a good handful of guys that know what they're doing. And the other ones are just like, hey, this is a market. We can sell some stuff. And you're
just trying to get into the market.
And that's what happens when an emerging market, it's exploded in the last 3-4 years.
Yeah.
So you're going to see a lot more players. You're going to see a lot more studies being done, which is really going to help us, because I think what's going to happen is that stuff that's really working, really case studies, that's going to be in this category. There's going to be other ones like, I'll keep a coil clean, maybe that'll work. And there's going to be these other guys over here, they're going to be like, we know that doesn't work anymore. And the word's going to get out.
Right.
So I think it's going to kind of
I think that's really important. So a couple of our core values: honesty and integrity, respect and value. The goal, even of these series and things like that, is we want to be educated and we want to help educate. Right. We're not in it just to put in just another product into somebody's house. We want to make sure that it's doing right by them. Right. Really valuing something that works well and gives them that return on investment, or gives them that quality of life. So I appreciate you spending the time here. If there's anybody who's looking to maybe get into this indoor air quality, right, or research, or even put something in their home or their place of work, would there be any advice that you would give them, just in some closing remarks? Yeah.
Well, first of all, I got to make a statement here. During a break, one of our other guys here said, "You said 50 parts per million. It's really 50 parts per billion."
Yeah.
I know.
Who's
going to know? Well, some scientist is going to say the guy's an idiot.
Yeah.
No, it's 50 parts per billion is what's outside ozone level.
Yeah.
Just a correction there.
Okay.
What was the question?
What advice would you give to somebody looking to get into this, right? Like looking to put it in their home, or even to research it a little bit more? Number one,
do your research, and research stuff that's outside. I'm going to tell you, go to our website.
Right. Yeah.
And we're not going to say that the SolaceAir doesn't work.
Right.
We're going to tell you all the wonderful things about it. You go to Honeywell's website, they're not going to say it doesn't work.
Right.
You go to some of these other, even the smoke and mirror guys, they're going to give you this test, the study that says it works. When you read a study, how was it done? If it's done in a little lab, that's great. Showed you how scientifically it worked.
Right.
Logically, did they do a test inside an air handler where it's coming by at 500 feet per minute inside of a home or inside of a building? That's the real world test.
Right.
So look for real world test. Look for studies that are outside of us, outside the manufacturers or what a contractor might say. What's the EPA saying? What's the World Health Association saying?
Right.
What's in Prism Engineering saying? I can name them on and on and on. There's who doesn't have skin in the game?
That's accrediting those things, yeah.
EPA,
absolutely.
I tell the guys this all the time. EPA's got studies on air quality. You can read they got a whole booklet on it.
Right.
I always say, well, how many air cleaners did EPA sell last year?
Yeah.
None.
Yeah.
They're not saying, let's make up the story so that we can sell air cleaners. They're saying, this is a study. Here's what it is. Indoor air is 2 to 5 times, can be 100 times worse than the outside air, just on the studies we've done. Here you go, guys. Do what you want with it. So since they don't have skin in the game, those are the studies that I would be reading. Now you know what's in the air, and they're going to tell you what controls it too. So now compare that to what you've learned on the technology side. And if it becomes difficult to understand, call me. I mean, The guys that we educate on the contractor end, we've got 100 core modules online the guys go through. We got certification classes that your guys go through.
Yeah, we've gone through a lot.
We come on site, we train your guys. We train them how to educate the homeowner in layman's terms. There's a lot involved, and rather than, we got a UV light, put it in.
Right.
No, it's a lot of education that you guys have already had. If you can't get the answer, you'll call your territory manager.
Sure.
If he doesn't know, he'll call me. If I don't know, I'll call an engineer.
Yeah.
If the engineers don't know, there's another engineering firm that we go to that's outside of even our engineers.
Yeah.
So that we have the information that they can get. So just lean on us for the information. Yes, we're the manufacturer. Yes, we're going to tell you it works, but we truly have product that scientifically works and logically works in the application it's designed for. So look at those two things. Look at research, make sure you're researching other than manufacturing's websites, and then compare it to what you're finding out of what works and what doesn't work, and kind of blend that together.
Yeah. Well, I'm sure we'll have a link in the description that we can share with you. You can also view some stuff on our website as well. And yeah, continue to do research. And I appreciate you being here with us, taking some time to come over here to Indiana.
It was fun. Appreciate you having me.
All right. Well, thanks for everything, guys. We'll see you again.
See you again.